All right. All right. Well, thanks everybody for joining us. My name is Paul. I'm the head of community here at Data Mesh Learning. Today we have an exciting talk with Andrew Jones, principal data engineer of GoCardless. And his talk is going to be data quality prevention is better than the cure. So yeah, before we get into the talk, I just have some community updates that I'll go over. So coming up next week on Tuesday, we'll have the monthly data mesh roundtable as usual, and that's going to be with Andrew Sharp, Amy Regatta, Karen Hawkinson, and Juanis Rosias. And then we also have a guest, Ole Olesen Bagnu, Chief Evangelist of Xenia. The topic is data catalogs. So we hope you can join us for that. That's an interactive session. So Ole will talk for a little bit, but then we have go over questions and people in the audience. It's a discussion. So yeah, I hope you can make it for that. We also have Marta Diaz, product manager for data platform at Adevinta. That's on June 26th, and that'll be at 9 a.m. San Francisco time or 1800 CET time. And that'll be all about the data mesh journey and Adevinta Spain. So yeah, we're excited to have Marta come talk with us later in the month. And then today, if you're in Belgium, if you happen to be Belgium, and I believe this is happening like right now or in a little bit, you can join Tom DeWolf, Steve Lowe, and Jean-Georges Perrin at a meetup at the Data Mesh Belgium meetup. And you can scan the QR code, the link there, so maybe you can catch the end of it if you're in Belgium right now. You should stay through the talk, and then you can go to the Belgium meetup. Of course, we post all of our past events on YouTube, or we're streaming live right now, so you can check that out. If you miss any of our events, they're always available there to check out later. If you're not already a part of the DML Slack group, you should do that. You can scan the QR code. You can interact with your peers, ask questions, data mesh questions, or you can help answer other people's questions. It's just a place for people to interact with each other and talk about data mesh. So you should scan the QR code and join the Slack group if you haven't already. And then, of course, as always, our data mesh learning website, we have a ton of resources, case studies, blog posts, and we list all our events there, so you can check that out. Okay, I'm going to stop sharing. Before I make any introductions, if you have questions, feel free to put them in the chat. We'll have Andrew answer those questions at the end of the meeting. So yeah, without further ado, I'll hand it over to Andrew to take it away.
Great, thanks, Paul. Hi everyone. So I'm going to talk a bit about data quality and why prevention is better than the cure. So think about data quality. If you're joining this live stream, you'll think about data quality a lot, right? You see the impact and the cost of poor data quality in day-to-day work, and you understand the need to improve data quality. But many organizations are not able to improve the quality of their data, at least not really. They're only able to work around the poor quality data, and they're doing so at great expense and with poor outcomes. So today I want to show you how we can prevent data quality issues at the source, because when it comes to data quality, prevention is better than the cure. So why is data quality important? Well, like I said, if you're joining this presentation, you probably understand why, right? You see it all the time. And this is backed up by a survey recently from DBT, who found that 57% of data practitioners highlight data quality as one of their chief obstacles in preparing data analysis. Actually, that's up from 41% from the last time they ran the survey. So it's getting worse. So we all understand why data quality is an issue, why it's getting in our way, why it's preventing us from delivering value. But on the other hand, we find that business leaders also aren't getting what they want from their data. So it's another survey, this time from Nash Squared, and it found that 64% of organizations think that big data analytics are the way to deliver competitive advantage. Yet only 1 in 5 are using it to deliver increased revenue. And this was a survey with business leaders. And I think what's interesting about this is it shows this massive gap between the aspirations of business leaders and what they want to get from the data, and reality they're seeing when they're seeing what is being delivered through the data and through the data teams. I think a lot of this is really down to how we deal with data and the quality of our data. Because we know that working with poor data quality is difficult, it's time consuming, and it's expensive. And it gets more expensive the later you leave it. So Gartner have a stat, as always, and they found that poor data quality costs organizations an average of $12.9 million a year. Now, I don't know how true that is, but I think having a way to demonstrate how expensive it is important. Because if we can do that, then we can get the resources we need, and more importantly, the alignment we need to improve the quality of the data at source. So we, as data practitioners, can deliver greater value for the organization. And one way I found quite recently to help articulate the cost of poor data quality is just 1-10-100 rule of data quality, which looks a bit like this. We'll go through it all in a bit more detail in a minute. But what it's saying is that the earlier you manage something, the cheaper it is. And that, as a rule, that feels almost universal, right? The obvious one being healthcare. So think about healthcare, it's much better for you and also cheaper for the health provider if people don't get sick in the first place. So we invest a lot in preventing illnesses. The next step would be when you do get sick, get treated quickly, get treated locally. Again, better outcome for you, cheaper for the healthcare provider. If it goes beyond that, then the costs go up and up and up. So with healthcare, we think about prevention a lot. Maybe an example a bit closer to us would be software engineering. And about software engineering, we spend a lot of time trying to prevent bad quality code from making its way into production. So we do a lot of things like unit testing, we do CI checks, we do code reviews, we might do pair programming. All these things slow down the delivery of code, but we do them because we understand that the cost of delivering poor quality code into production and causing incidents is high. So we invest in prevention. Obviously, we don't prevent every bug making its way into production. So we still do remediation and we still invest a lot there. And software engineering, that's around observability, have a good incident management process, rolling back quickly, feature flagging, all those things help with remediation. Failure in this case would be just kind of writing code in production on a server, which obviously no one's doing unless you're like a student. But again, with software engineering, we invest a lot in prevention. With data quality, we don't tend to invest that much in prevention. And that's what I want to talk about in the next few slides, is how we can start thinking a bit more about prevention when it comes to data quality. So let's go through this 1-10 rule, 1-10-100 rule in a bit more in detail with data quality. And when it comes to data quality, what the dollar figures mean is the cost per record. So if you fail to do anything about data quality, you look at $100 per record. Remediation is $10 per record. Prevention is $1 per record. So let's go through the pyramid now. We'll go bottom up from failure up to prevention. So look at a failure, which is $100 per record. This is where you have data, but it's not accessible, it's not usable. You've done nothing to try and organize it or to try and improve quality of it. And then maybe you give up. So then the $100 includes the opportunity cost of not being able to deliver what you need to deliver for your organization. And then maybe then your organization can't meet its strategic goals, and then your company becomes less competitive over time. And the $100 includes all of that as well. So not a great place to be. Again, I think if you're joining this call, you're probably doing something about data quality. So I'll be surprised if anyone's in failure. I think most of us will be thinking about remediation. And this is where I'm spending a lot of our focus at the moment as an industry. And this is things like observability, things like using something like Soda or Great Reputations to implement checks, send alerts when data quality issues are found. All of those kind of things come under remediation. And this is good. It's good that it helps you notice issues quicker, maybe helps you recover quicker from incidents. So it's good, but there's still a cost. We're still talking about $10 per record here. And the reason there's still a high cost is because often these observability, these alerts, they often alert you when poor quality data is already in production. It's already causing an incident. It's already affecting users. And maybe the data is already in many different places. It's gone to other systems. And that all adds to the cost of dealing with that incident. Also, once we notice an issue and we've worked out what went wrong, it tends to be too late to implement the fix upstream in the source system where it occurred. So what we end up doing is we implement workarounds downstream in our ETL. That'd be, as I'm sure you know, that'd be another coalesce statement, another if-else statement, all those kind of things where we're working around the poor quality of our data. And the problem with that is, it looks okay if you do it once or twice. If you keep doing that, your ETL becomes increasingly expensive and increasingly complex. And that complexity on its own leads to more data issues. And if you keep having all these data issues, your users will start to lose trust in your data. And once they lose that trust, it's very difficult to win it back. So remediation is good, but it's still costly. So what about prevention, where it's cheapest and most effective to deal with, to improve the quality of data? Like I said, this is probably where many of us aren't focusing too much at the moment. Most of us get to remediation, and that's where we operate. Few of us are going towards prevention. But what prevention looks like is all about things like shifting left, catching issues at the source. It's about preventing common issues from occurring in the first place through good change management processes and things like that. And it's about ensuring that when an incident does happen, there's a reduced impact. Maybe preventing that poor data from leaving the source system. And that means that it can be fixed at the source and the data can be replaced from the source. And that can be done before that poor data ends up in the ETL and then in all the downstream services that are powered from that. So, like I said, though, most of us aren't thinking too much about prevention at the moment. Most of us are getting to remediation. So the next few slides, let's focus on prevention and what it would take for us to start preventing more data quality problems at the source. So if we start by taking this pyramid, this 1 to 100 rule of data quality, and overlaying it on a simple data pipeline, it might look a bit like this. So $100 per record, failure, that's when issues make great applications and affect end users, potentially paying users of your product. Remediation, that's what we do in pipelines, like I spoke about already, or you have to do in your ETL to try and manage poor data quality. Prevention is at the source, it's on the source data. And that's where it's cheapest and most effective to deal with poor data quality. But how do you do that? But how do you actually prevent data quality issues at the source? And how do we incentivize data producers to put a bit more effort and a bit more discipline into the production of data so that we can prevent some of these common data quality issues from occurring completely? Well, I think first of all, what we need to do is we need to correctly assign responsibility of that data to the right people. And for many of us, that would be assigning responsibility for the source data to the product engineering or the software engineering functions in organizations. Now, ultimately, they should be responsible for the source data. And that, they may not feel that way today, right, in your organization. But think about it, they're the only ones who can be responsible for it. Because they're the only ones who can impact the quality of their data. There's nothing we can do downstream to make it more timely. Nothing we can do downstream to make it more complete, to make it more accurate. Best we can do is work around those issues, maybe infer data or techniques like that. But we can never really do much more than that to improve the quality of data. So responsibility has to lie with the people at the source generating data, which typically is a product engineering team. So if that's the case, and if I don't feel like responsible at the moment, then what do we do next? How do we incentivize them to take on that responsibility? How do we make them care about data quality? How do we provide them the right tools to help them produce data of the right quality, of quality we need it? I think there are a few things to know that we need to do. And in particular, I think there are two problems we need to solve. The first is that currently there's a huge gap between those producing data and those consuming data, actually driving value from the data. So those coming in last mile, creating value, those data science teams, those BI analysts, those people using the data to drive real value for business. They are so far away from where this data is actually being generated. Often they're getting data through another team or through many different teams in the middle. Typically a data engineering team, maybe for like a platform team, could be anyone. But there's a huge gap between those providing the data and those consuming data. And that means as a data consumer, you're kind of stuck with what you're given. Like if the data isn't what you need, isn't right quality for you, if it breaks regularly, you can talk to the data engineering team, might be able to do some working around that, but you might not even know who actually is generating data out of the source. It's very difficult for you to find out and speak to them and have a conversation about why you need it to be of better quality and how that impacts the business as a whole, how that improves outcomes for business. On the other side, if you're a product engineer or software engineer or product manager in a product engineering team, you don't really know how your data is being used to create value. You're too far away from it. And then why would you care about data quality if you don't see the value it's provided for a company? Like you wouldn't. You've got a million things you need to do. Why would you care? So I think we need to really encourage greater collaboration between these two areas, between those consuming data and those producing data, to bring them a lot closer together. And to do that, we, as data practitioners, as people actually getting value from data, we need to be really good at articulating the value of what we're providing. So why do we need this data? What value is it generating from a company? Why would better quality data help us? And if we do that and do that well, there's no reason why we can't incentivize the data producers to provide data that meets our requirements and that have the right quality for us to deliver what we're delivering. The second problem I think we need to solve is this lack of interfaces. So often we are getting data through some kind of ELT or change data capture style process. And what that is doing is just grabbing data out of the source databases or other third-party tools, grabbing that data, chucking it into a data warehouse or data lake, and then we're building on top of that. And many problems about one of the main problems is that we are effectively building directly on top of that source database. And this source database is going to change. Like product engineers need to change that database as they do features, as they improve performance, or do any of the number of things they are trying to do, they need to do to deliver what they need to deliver. So we should be expecting that to change. And yet we are so often caught out by that change because we're building directly on top of a database and because there's no interface in between that database and the data we're building on. So that's another thing I think we need to solve. We need a more explicit interface through which data can be provided from the source databases to us so we can build it with confidence. Now, interfaces, they're a simple idea, but also very powerful. And that's why we see them everywhere in software engineering. So for example, think about a Python library you're using. What you're doing there is you're using a public interface. And you know that it doesn't matter like what's going on behind the scenes or with private methods. You can rely on that interface not changing through different minor versions. One day there will be a change, a breaking change, and they'll produce a new major version of a library, and probably via some sort of migration path from the, say, version 1 to version 2. So that's a great example for interface. You're using something you build on with confidence. Now, if you're using Python or similar language, you can technically go and access the private methods of that library. And if you're doing that, you have none of those same expectations. The library author can change that anytime they like, and if that breaks your thing, that's on you. But if you go through the interface, there's an agreement, there's an almost silent agreement you're making there, where the provider of the library is going to commit to providing that interface until they create a new major version. So library is a good example. API is another good example. Think about a company like Stripe or Slack or us. I work for GoCardless, so a company like us. We provide an API that allows other businesses to build entire businesses on top of our APIs as a platform. And they can do so in confidence, knowing that we will have good change management on the API, we won't break it without telling them, and if we do, there'll be a migration path. They know that we are committing to certain SLAs, and that gives them a certain level of confidence in terms of the uptime, the latency, all of those kind of things. It's what allows them to build on that with confidence. And also us as an API provider or an interface provider, it's very clear to us what our responsibilities are. So again, interfaces is very simple, but you see them everywhere in software engineering because they're very powerful. They help you assign responsibility. They help enable greater collaboration. You've got something to talk around, something to discuss around, something to agree on. And they, most importantly, allow things to change on one side without breaking things on the other side. To take the API example again, Stripe, Slack, GoCardless, we're changing things all the time internally. Doesn't affect anyone downstream of us building on top of that interface. So the interfaces are really important, but we don't see them often in data engineering. And I think for data, we can use the data contract as the interface. So what is data contract? And apart from the interface, how does it help us prevent data quality issues? Well, I think the easiest way to think about a data contract is it's a set of metadata about your data. And again, simple idea, but very powerful. When you start describing your data, and you can describe it in any way you need to match what your requirements are. So that could be things like having a schema, could be having SLOs, things like having categorizations, like the personal data, not personal data, anything you need really. When you start describing your data in a standard way, you can then do a lot with a data contract that helps us prevent data quality issues at the source. So for example, we can use data contract to encourage collaboration. So as I mentioned earlier, it's kind of on us as data consumers to really feed into the data contract, provide our requirements, articulate the value, quantify the ROI, maybe encourage that and foster that collaboration, put the effort in. And if we could do that, then we can, data producers will take on responsibility. They'll take on responsibility for quality of data. They'll take on responsibility for how the schema evolves, apply some change management around that. They'll start providing citations and SLOs around the data that meet our requirements or get as close as they can to our requirements. So again, there's kind of discussion there, collaboration needed. So we can use data contract. Once you have something describing what you need and what's being provided, you can use data contract to encourage greater collaboration. You can also use data contract to create this interface I've been talking about. So the way most people define data contracts, and the best way to define data contract is in a format that's also machine readable. And if it's machine readable, maybe it's in YAML, maybe it's in code, maybe it's in Python, doesn't really matter. But if it's machine readable, it's then very easy to create interfaces from that data contract. And once you have that interface, you can then allow or enable data producers to provide data through that interface. So this interface in practical terms will be something like a table in a data warehouse or stream, a Kafka stream, or whatever, again, whatever you need really, not prescribed. But once you have this interface, you can start providing change management around it. And now you're no longer building on top of someone else's database, you're building on top of that interface instead. And this allows you to catch issues at the source, and it allows you to prevent many common issues from occurring. And the nice thing about this is that, again, if we do this and we do this well, what I have is we have product engineers producing quality data for a well-defined, stable interface. And if they're doing that, maybe it doesn't need to go through the engineering anymore. Maybe it's good enough to use directly. And that allows us to bring the producers and consumers a lot closer together, enabling that collaboration again. Also removes that bottleneck of data engineering. So I'm sure some of you work in the engineering team, you always got a backlog that's too big. You never get to many of the things on that backlog. It's a bottleneck. And bottlenecks are there to be removed. So this is one way to try and move that bottleneck. Doesn't mean we're not going to have any more data engineering, but doesn't have to be default. Not all data needs to be refined through data engineering to become useful. Now, this is a presentation for the data mesh learning community. Imagine many of you are at least a bit familiar with data mesh or have heard data mesh. And some of you are probably thinking, a lot of it sounds a bit like data mesh, like the things we want to achieve with data mesh. And you're right, you're right, it does. And that's not an accident. The way I see data contracts, it can be a step towards data mesh because there are strong alignments between the goals, what we're trying to achieve through data contracts and what we're trying to achieve through data mesh. We're trying to solve the same problems. Actually, when I think about data contracts and when I started thinking about data contracts originally, it was around 4 to 5 years ago. And I was trying to solve these problems at my organization, thinking about why data kept breaking and causing all these outages and causing all these incidents downstream. And I was thinking about interfaces and things like that. I was also the same sort of time when the data mesh articles came out from Shamrock originally. I was reading those articles and they're definitely one of the inspirations behind my ideas behind data contracts. I really liked very articulated problems we want to solve and like the solution they're describing. But at the time, I was just a tech lead of a data platform team. I was a very small data platform team. I felt like I couldn't go and try and change the whole organizational structure to try and help us improve quality of our data. That was too big a problem for me to solve. But providing become new language data contracts, providing a bit of tooling that helped enable that, talking with certain teams and working on specific problems using this kind of new language and supporting a move towards a more decentralized organization. That was something I could do from where I was in the organization, sort of bottom-up approach towards data mesh. And data contracts helped us to do that. So if you think about data mesh, it's got its 4 principles, and each of these can be delivered through a data contract. So the first one, if you're not familiar, is around data domain ownership of data. And I won't go into much detail today, but basically data mesh is all about data being owned by those who generate it. That's why I have most knowledgeable people about the data. Second principle data mesh is data product, data's product. And this is around responsibility partly, around data owners taking responsibility for the quality of that product and making sure that product meets the requirements of its users. Third principle of data mesh is around self-serve data platform and providing infrastructure that supports these autonomous teams so they can build and manage their own data products and do so independently. And fourth one is around federated data governance. A governance implemented through a federated model, balancing the need for central oversight with autonomy of data domain teams. And like I said, each of these principles can quite easily be delivered through data contracts. Let's quickly go through those in turn. With domain ownership, I've already spoken a lot about how through data contracts, we want to try and define ownership and define responsibilities and use it to encourage greater collaboration between the owner of the data, might be in a certain domain, and the users of data who might be in other domains. Data contracts help to that. In terms of treating data as a product, if you're creating a product, you need some sort of interface to deliver that product. And I've always spoken a lot about interfaces, and data contracts deliver those interfaces. And it does so in a standard way so that it helps enable that discoverability and interoperability between data products. If you're all using the same tooling, the same language, the same APIs, the same interfaces. In terms of a self-serve data platform, I haven't got time to talk about that today, but I talk about it in other places like my book and my newsletter. But this idea of like building a platform around data contracts is something that we've done at GoCardless where I work. I've seen other organizations do it as well. And really can use data contracts to drive a complete data platform built around data products, around data contracts. And finally, data governance. Again, not much time to talk about it here today, but I've talked about it in other places. But you can really embed and even automate a lot of data governance through the data platform by capturing what you need to capture in the data contract and building the right sort of tooling and the right sort of platform to either embed it or automate it away completely. Again, that's something that we do here at GoCardless. So I really like to think of data contracts as a step on the ladder towards a data mesh. So I think one of the drawbacks, one of the criticisms of data mesh is that it can feel like a big change organization. And depending on where you are in an organization, that can be too out of reach, too far. Data contracts can help you get started on that journey, almost by stealth. Then maybe you want to introduce a bit more language on data products, and maybe you get to data mesh, but you're on a journey and you're delivering value all the way through at each step. And who knows, maybe data contracts or maybe data products, that might be all you need for now. You might not need to go all the way to data mesh to deliver what you need to do at your organization. So to summarize what we spoke about today, well, we started off talking about this kind of gap between the aspirations of organization leaders, business leaders, and reality of what they are seeing when it comes to what they are achieving through the data. And we also saw a stat from DBT around how data quality is one of the major contributions that's preventing us from delivering through the data. So I think data quality is one of the things that really preventing organizations from getting value from data. I think to solve that problem, we need to think again about how we are dealing with data, how we're trying to improve data quality, and really move not just from the remediation step, but back to prevention. How can we start addressing data quality at the source? To do that, we need to improve collaboration between those creating and those consuming data. And we need interfaces through which data can be provided that is stable and that is of right quality for the users. So I think over the last 10, 15 years or so, data engineering has been too difficult, it's been too expensive. And because of that, we're not delivering what we need to deliver. To articulate those problems, the 1 to 10, 100 rule is a great way to articulate that, to describe that, to get some buy-in for that. Because what it does is it talks about costs, which is a good argument to make when you're trying to make a big change. And when it comes to data quality, the highest costs are when you're doing nothing to try and address data quality. It's much cheaper to do what we're doing now, or for stuff around observability, or stuff in remediation step, the alerting. But it's much cheaper still if we can prevent these issues from occurring in the first place. And data contracts helps with that. Because when it comes to data quality, prevention is better than the cure. Thank you.
All right, thanks, Andrew. Yeah, I think that that last graphic you showed, that's what everybody should use to help drive organizational change towards data mesh. And a good example of why data contracts can be useful because it all comes down to saving money. I'm sure that's a
Yes.
huge draw. Um, yeah, thanks a lot. We have some questions here, so I will read them off. So from Diane, oops, what happened to the question? There we go. Diana Borovic. Just wanted to ask, what would be the definition of data quality and data quality issues? Specifically, the definition for collaboration between engineering teams and data engineers.
Yeah, it's a good question. For me, I think data quality yeah, is one of those terms that is used a lot in a lot of different contexts. Um, I think for me, it's about the expectations that you get from data. So if you're telling me that there's more about the expectations rather than hitting a particular level of data quality. So if you're telling me your data is going to be available daily, um, and that you won't make breaking changes until you create a new version, that to me is you're defining some data quality measures. And as long as you're telling me what to expect from that, I can build on that data with some confidence. It might not exactly what I mean. Maybe I'll drive it hourly, but at least I know now and I can build it with some level of confidence. I think what we have at the moment typically is there's no expectation set. So you don't know how the scheme's going to evolve. It might just change overnight and take everything downstream. You don't know how timely it's going to be. It's not really been defined or set. So then what you end up doing is make assumptions about what it'll be based on what it currently is. Well, it hasn't broken in months, so I think it's very stable and it seems to be up to date to the hour. So I'll assume that. But if you're assuming that and that's not what the people providing the source, then one day that assumption's going to break. Something's going to break your assumptions. And you might build something that's critical of business, and now you're not, now it's falling down and everyone's asking you why. You're like, well, I thought it was going to be, I thought it was going to be up all the time, and I thought it was going to be hourly. So I think it's really about expectations when it comes to data quality. I think that's the most important part, and the actual measurements themselves are less important. So yeah, I hope that answers your question, Diana. It's a bit of a broad answer, but I think it really depends on, yeah. As long as you know what it is, then you have some confidence when building on it. And if you don't know what it is, then that's when big problems happen.
Okay, cool. And then Diana actually had a follow-up. So it said the definition, which is supposed to help to set the line, where are the issues to be fixed by engineering teams, and what data engineers may tolerate and implement cleansing procedures for? Or
Well, yeah, it's a good follow-up question. I think it's interesting language in that question. Actually, the words like tolerate and cleansing. And I think that speaks to how we've been dealing with data for the last probably like 15 years or so, since the Duke scene really, and HDFS and became cheaper to store data, and we had all these ideas like schema reads, all those kind of things. Is that once we started thinking about those architectures, we really um, focused on making it too easy to collect data and too hard to use data. And that's why data engineering is so hard. We have to tolerate poor quality data, we have to cleanse it, we have to refine it, use the whole data as an oil language, which again is kind of problematic. And you could argue that's maybe okay if we're just doing analytics. I'm not sure that's true, but you could argue that. But I think when you're using data to provide key product features or to drive key business processes that may be important for regulatory reasons, if you're an issue like mine, it's not okay for us to tolerate those things anymore. Like if we want these things to be reliable, we want to provide a product feature that drives revenue. It's based on maybe data directly or based on ML built on that data or whatever it might be. We need to have that quality from the start and the reliability from the start. Otherwise, it can't be reliable downstream. So obviously this doesn't apply to all data, but I think if you're using data for those kind of business critical things, then you shouldn't be tolerating these kind of issues, you should be having those conversations, like many other conversations in the company. Whenever you have meetings depending on each other, you should be having conversations about, okay, to deliver this critical thing for a company, I need this quality data with these expectations set. If I can't deliver that. I mean, have those conversations with them and move away from this idea of being get well given and being lucky to have that at least.
Yeah, I guess that's also part of the shift in organizational thinking
Yeah, I think
that
that's
you're
where the
talking
industry's
about.
moving. I spoke to someone earlier about this actually on a different Zoom call. I mean, industry does seem to be moving in this way. It will happen more quickly in some areas and a different speeds in other areas. It's a big change. But where I work, we have changed that culture where we don't expect data engineers to spend the time cleaning and cleansing. We expect them to be delivering business value. And if they need better quality data upstream to do that, then we'll go and ask for that and we'll make the case of that and we'll get prioritized in the same way that anything is prioritized in the company. So we engage with OKRs and costly planning, all those kind of things. It's just because part of something we do, it's not different to any other dependency that a team has. And I think that's the way many organizations are moving.
Yeah, well, that's sort of what you just said there ties into what Martin Harrison was asking. So, are any clients you know actually delivering the data quality standards you describe so they don't get issues? And one, it sounds like the organization you're working for now is doing that.
Yeah, certainly where we're working from. So I'm talking from mainly first-hand experience here. My work at GoCardless. Aside from GoCardless, I sometimes speak to other organizations, and there are many that are looking at this. I don't want to name them, but they're actually often quite large companies, quite tech-heavy companies, to be fair. Well, not always. Sometimes they're media companies, sometimes they're banks. So even banks, financial organizations that are seen as slow moving. They are also roll out their contracts to try and solve problems I spoke about earlier, to try and improve quality, try and drive standards around that. Um, so I think it's certainly it's certainly becoming a more widespread idea for sure, and we're seeing it more and more.
Well, we'll try and find a company who's willing to talk about implementing data contracts. Yeah, I know it's probably a little sensitive about who you can actually
Yeah, I'm
say.
making permission to speak about them directly, so I don't want to. But there are some who spoke about it publicly already. So HelloFresh, I think, used to take contracts, and they spoke about it publicly before. Um, if you obviously know, you might have heard of many different companies building their contract solutions. So Chas Anderson building Gable has many customers. Again, I don't name them, but if you follow him on LinkedIn, he talks about some of the customers or the people he knows of using their contracts. He's posted about it recently with some various logos on there. So there are public examples too. PayPal. So obviously JDP is a friend of
Sure.
email. So there are good examples out there that are public as well, if you search for them.
Yeah, maybe we should have JGP come talk about his experience at PayPal implementing data contracts. I'm sure he would love to do that. Okay. Then last question we have from Richard Atkins is, please give an example of how we use the codified contract, such as YAML. Is this just a representation of what's at source or used by ELT, or a definition of the source itself?
Yeah, I see a question. I think last time I think I'll say it's not. But I'm guessing, or what I'm reading from your very questions phrase, like the idea of it being represented at the source, makes it sound like to me like you're thinking of data contract describes maybe a table in a database, and you're kind of codifying that in a way. And I see people do this, and there are pros and cons to it, but I don't like that approach so much because I think you're still tying yourself to that database, to that table, to how it's described in that upstream service. And I think what you really want is some sort of abstraction there, some sort of separation. So when we talk about data contracts, and when I talk about data contracts in the book and what we've done at GoCardless, it's separate from the table, separate from the database. It's not a representation of what it looks like in the source database. It's a it's a representation of what that service is providing to downstream downstream consumers. So it might look a bit like a table, but it might look completely different, and probably will look different. Because what we're talking about here is providing data in the right format that meets the requirements of people downstream. And often that will look different to what looks like in a transactional database. It might be more designed for analytical use cases, might be more of an event stream if you're doing event streaming in your organizations. But it shouldn't look like a source database itself. It should be different. And that allows source database to change over time, while not changing that data contract, not changing that data product, if you like. So I think that's one thing. And then it's also the same representation that's used by the ETL in that case. So, I think, yeah, so it says ERT in the question. So yes, I think that reinforces what I was saying before. Like, it's not about using data contracts with ELT, with change data capture, with those kind of processes that basically make copies of database and brings them into your data warehouse, your data lake. You can do that, but I think there's limited benefits to that, very limited benefits. I think what we really want to do is move away from building on top of those databases directly and having a different kind of interface. And to be fair, that is more work, particularly on the data producer side, but we can help with that. We can provide libraries to help with that. There's different architectural patterns to use of that, which I haven't got time to go into now, but it's things like the outbox pattern, things like listen to yourself. I discovered in the book, and there's things online about it. They're not new data contracts. They are kind of patterns getting microservice architectures. But I think we need to adopt the same kind of patterns because what we're building with data is as important as maybe another microservice or another service somewhere else. So why shouldn't we have the same expectations from the data? Why shouldn't we have an interface, an API, something that doesn't look like the database? I think it's all the same, really. And I think that's why, yeah, I wouldn't codify the source system, source database. I think about how you can codify a new interface for that data.
So do you mean like kind of like the API that to access that data?
Yeah, so it could be an API. Typically, because we're looking at data sets, it'll probably be a table in data warehouse. So what we do is people define a data contract. They do it in a form of code for us. It's not YAML, it's a form of code, and we do that because that was the most natural thing for us to do. It's the same way people in GoCardless define the infrastructure as code and the APIs, we just did it the same sort of way because deliberately because we wanted it to feel the same we wanted it to feel the same for them. And then what we do is we take that code and we generate for our case, BigQuery from Google, a BigQuery table, and that's the interface. And then we say, you as a service need to write to that BigQuery table directly. We also use this for streaming, so we use Google PubSub, and we say, okay, you as a service now need to stream that data through PubSub. Often they're used together, so you stream to PubSub and write to BigQuery. But what we're doing there is we're creating that abstraction, creating that different interface. And then on the consumer side, producer side, to make it as easy as possible, we've, like I said, we're providing libraries for people to make use of patterns like outputs and things like that to make it easy to get data into PubSub or into BigQuery that matches their performance requirements and makes it as easy as possible for them. While also, but it is still more effort than like CDC and ELT. It's doing some work, but we've made the case that overall that's a better outcome for the company.
Okay, thanks. Well, I think, well, are there any more questions? I'll wait a second because there's a little bit of delay. If there are any more questions, go ahead and add them to the chat now. We'll just
Yeah,
hold.
really good questions. Thank you, everyone.
Yeah. Yeah, thank you everybody for your questions so far. I think they were great. Well, I believe we're done with the questions. So yeah, I just want to say a special thank you to Andrew. Really appreciate you taking the time to speak with us. Yeah, this is fascinating, and of course we'll post this online. So if you want to watch it again, you can watch it on our YouTube channel. But yeah, thank you, Andrew, for joining us today.
Cool, thanks, Paul. Thanks for having me.
Yeah. All right. Well, we'll see you later. All right. Thanks, everybody. Bye.